Hi, I'm Professor Kelly, and this is a lecture on diagramming in Java memory for CSCI 308 Programming Language Design. Learning goals for this lecture are distinguished between three different parts of memory: the stack, the heap, and globals, to draw diagrams of primitives, references, objects, and arrays, and to modify diagrams to show changes in state. In imperative languages, that is, languages like Python, C++, and Java, and not languages like Prolog, memory is typically divided into three parts: globals, for storing global variables; the stack, for storing calls to functions, and the parameters and local variables for each function. Each function's environment on the stack is called a stack frame; and the heap, which is for storing stuff. In Java, there are no globals. Java does have a stack and a heap. The stack stores method calls and variables local to the methods, including references. The references refer to things on the heap. The heap stores classes and objects and performs garbage collection, removing any objects to which there are no pointers still in the stack. When the program is finished running, everything on the stack is deleted. Java stores data types in three ways depending on whether the data is a primitive, a reference, or an array. Each has a different layout in memory. Int, double, byte, char, and boolean are all primitive types. Their memory is drawn as a box with a name, type, and value. When the data is changed, we reuse the same box of memory. Classes in Java have the formal type of reference. References are drawn as a box with a name and a type. The data in the box is always an arrow which points somewhere else. When references are initialized, they point to an object of their type, which contains boxes for all of the object's properties. Be careful, some of the object's properties may themselves be references, such as the name strings in these snowman objects. When the data in a reference changes, the reference will point to a new place. Any class objects with no pointers to them will be deleted by the garbage collector. Strings are immutable, so any changes means they get a new box. Arrays are a special case. The array cells contain either a primitive or a reference, depending on what type they contain. You have to actually call the object constructor for an array of objects to instantiate an object. Learning goals are to distinguish between three parts of memory: stack, heap, and globals. The globals part of memory stores global variables. It doesn't exist in Java. In Java, the stack stores local variables, parameters, and references to things on the heap, as well as function or method calls. The heap stores classes and objects. We learn to draw diagrams of primitives, references, objects, and arrays, and to modify those diagrams to show changes in state. Primitives are boxes with values, and those values can change. References are arrows, and those can be redirected. Objects can be garbage collected when there are no arrows pointing to them. Arrays are a reference to a 0 to n series of primitives or references.